what this has is diprotic. See, there's 2 protons on this thing. So what's neat is CO2 in water. CO2, the gas, you breathe it in, you do it in your cells, all of a sudden your cells are expelling CO2, it runs into water. Carbonic acid is what this makes. So even when you're drinking pure water, the CO2 in the atmosphere is forcing a little bit of that in. It's making carbonic acid here. So what's the beauty of this? The pH of your blood needs to be at a certain temperature, certain pH. So say you got an excess of acids coming, well, carbonate can take a proton or it can give one up. So it keeps everything in equilibrium. So let's show what this looks like drawn as a chemist right here. We got CO2 in the air. C double bond O, double bond O. CO2 plus water, H2O, goes on to make H2CO3. Without the reflection, if you were to look at that, it doesn't show up very good. That's zoom it in, just focus on it for a second here. CO2 plus water, we'll draw water in there. Do it our way here, right? Diamond. Color black diamond. CO2, double bonds. See, so these would look real familiar after you do this a couple times, right? Diamond, 2 circles. Dot. Dot. H2O. And we're going to bond these all together now. So this is where you really learn this, because see, carbon with the diamond is only going to have 4 bonds on it. So people want to start putting the H's on there and stuff. It doesn't work that way. They do oxygen, what always has double bonds. Well, you got 3 oxygens, so you're going to have to go 1, 2, 3 of the oxygens right there. So only one of them is going to be able to get a double bond. Well, we know the oxygen always has 2, right? So that's going to have to get the dots on it. So this is what carbonic acid looks like with our Schroeder diamonds. Write this up here for those that are looking. Carbonic acid. Diprotic, 2 protons it has to give up. This is from the CO2 in the air in water. When you're drinking your soda pop, pop the can, right? What comes out? CO2 gas. Well, what was the CO2 doing in there? They pump the gas in, and what does it react with? The water. So you actually have carbonic acid is in your soda pop. You open the soda pop, the carbonic acid lets the CO2 come out, and you're left with water. So water is a beautiful chemical to talk about, because the concept of pH is all based on these protons coming and going. And bicarbonate, see, it starts getting different names in here. That's what's so confusing about it, because if you take away one of these protons, you got a pair of electrons here, which gives the thing an overall minus charge. So now it's 1H CO3 minus. That's called bicarbonate acid, bicarbonate ion. Bi means 2. Well, there's 2 and nothing here. There's 3 oxygens, 1 carbon, 1 hydrogen. So where does the name bi even fit into that thing? And even I'm confused now, because one is hydrogen carbonate and bicarbonate. I put that on my table here to remind me when I did do that. Where did I put that? Down here, sodium bicarbonate. So if you take away one proton, it's bicarbonate. So this is called the bicarbonate. And we're here. We don't have the electronic mics, so this mic will always be on. Catch that in the background. So it's Cosmic Ray, the quantum mechanic. We're here today. We're going to do some new chemistry stuff.